Let's try a related rates problem that's kind of abstract. Suppose that y is equal to 2x cubed minus 5x squared, and let's find dy dt when x is negative 1 and dx dt is 10. So for a problem like this, there's no word problem to start with. We just can kind of jump right in. Remember that the basic formula is that the rate of change of y with respect to time is equal to the rate of change of y with respect to x times the rate of change of x with respect to time. Well, dy dx is just the ordinary derivative of this function. So in this case, that's going to be 6x squared minus 10x. And dx dt we were given was 10. So we'll put that in over here as 10. Well, finally, we just have to plug in x equals negative 1. So I get 6 times negative 1 squared minus 10 times negative 1, all of that times 10. And at this point, we just have to be careful with our arithmetic. So 6 times negative 1 squared is 1, so that's just 6. Minus 10 times negative 1 is minus a negative 10, so plus 10. And so we end up with just 16 times 10, or 160. So it's really kind of straightforward. Let me show you just another way you can approach this that is really the same, and some of you might prefer to think about it this way, which is basically that you can just think of y and x as being functions of t everywhere and just use the chain rule. In other words, essentially I'm going to take the derivative with respect to t of the left side and the derivative with respect to t of the right side. So the derivative of y with respect to t, that's just what we call dy dt. And then on the right side, you can kind of do these two terms separately. You say, well, the derivative of 2x cubed with respect to x would be 6x squared. But because there's a mismatch of the variables here, I should multiply that by dx dt. And then same kind of thing here. The derivative of 5x squared becomes 10x times dx dt. And in fact, this is really the same thing as what we did up here. The only difference is that in the first case, the dx dt was kind of factored to the outside, whereas down here it's in each individual term. But of course that doesn't matter. If I fill in x equals negative 1 and dx dt equals 10, then I'll get the same thing as before. 6 times negative 1 squared times 10, minus 10 times negative 1 times 10, and that's still going to get you 160. So feel free to think about it and work a problem out like this in either of these two ways.